Hi there, I'm Hao. This is just another video of me solving randomly code problem. Given an array of integer nums in integer k, return the total number of subarray whose sum equals to k. A subarray is a continuous non-empty sequence of element within an array. So we can pick this, we can pick this, but we cannot jump around like this. Okay, so that is a subarray. So we can keep track of the sum, the prefix sum, up to a certain index, right? So let's say we have 1928, 1928, 1171. Let's say our k is 10, k is 10, 9, right? And it is our index. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And we can keep track of what? Keep track of the sum up to index, right? And then their frequency. Okay. We can start at 0, right? This is a valid subarray, right? An empty subarray is a valid subarray, right? And then um, this subarray make up to the sum of 0. So that's why we start out at 0, right? The sum of 0, there's one way, there's one subarray to make up to the sum of 0, at least, right? There will always be a subarray that make up to the sum of 0, which is an empty array, right? So I can put it here, okay? And we can like iterate through the whole array and keep track of the frequency, right? So 1 up here one time, 1 plus 9 is 10 up here one time. Okay, so remember, because it is a positive integer array, we can have negative integer as well, right? But in this example, all numbers are positive. So what does it mean? It means that we will never reach the same sum again, right? It's just gonna keep getting larger and larger because we don't have negative number, right? So we will never reach the same sum again. So let me just go ahead and then speed this up. So 11, no, 10, sorry, 12, 10, and then 12, and then 20, right? 21, 22, 22, 29, 30 and 39, 30 and 39, right? And each of them will appear exactly 1 because all numbers are positive in this particular example, right? Don't forget our index 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So if we look at 10 here, right? This range, what does it mean? It means that the range from so an empty array, right, is 0, right? So I can just write 0 here. So this range 0 from empty array to index 1, right? And the second range is from 0 to 1, right? So the sum of 10, right, minus uh minus 0, right, is 10. Sorry, 10 minus 10 is 0, right? The 10 is our current sum. So current sum, right, minus k, right, which is our target, right? So here 10 minus 10 is 0, right? We have our current sum, we have our target. So if we have the remaining, which means there is a way, there's a subarray that where the sum make up to the target, right? So we can ask ourselves how many subarray there is that can make up to the sum of 0, right? Which we only find out here, right? Which is one way. The frequency is 1. So we can have our count, right? Starting at 0, and we can add the frequency to the count, which is 1 here. Okay. Uh, okay. Let me change color. It's a little bit hard to see. Okay. If you look at the range from 20 here, right? 20 to 10. It is 10. 20 to 10, right? So the sum up to index 3 is 20, right? And the sum up to index 1 is 10, right? Is 10 here. So we take our current sum because we are at index 3 now, right? We minus our target, which is 10. We get 10, the remaining. So if we have this sum, then it means that there exists a subarray that can make up to the sum of 10. Okay, so we look at 10, we see that exists in our hash map. We have 1, so we add that to our counts, right, so on and so forth. Okay, we also have I think 3 more, so 22 to 12, 22 to 12, 22 to 12 to 10, which is our target, and then 30 to 20, right? 30 minus 20, 20 is 10, and then 39 to 29, right? So our total would be 5. There's 5 subarray that make up the sum of 10, right? 1 and 9, right? Right here, this is 10, yeah, 1 and 9. From index 2 to index 5, so 2 to 3, 2, 8, 10, 10. Another one would be 8, 1, 1, right? Also 10. And then 1, 1, 7, 1, also 10. 1, 1, 7, 1 would be the index from 3 to 7, right? This one and this one, 3 to 7, right? Index 3 to 7, right? This is the range, right? So the difference is in this range, right? So 0 to 7, 0 to 7, yeah. And then 0 to 3. So the difference would be from 4 to 7, right? So 1, 1, 7, 1, which add up to the target. Okay, so 1, 2, 3, 4. The last one is 1 and 9, right? Which is from index 6 to 8. So in the sum for at index 8 minus the sum at index 6. Okay? This is our result. So that works. But what if we have negative numbers, right? If we have negative number, then what does it mean? It means that there's a potential chance that we will see the sum more than one time, right? So let's look at that example. Okay. Okay, so let's look at we have 1, -1, and 0, right? So we start at 0, of course. So we look at 1, like the sum at index 0 is 1, right? And then we look at the next one, our sum is 1, right? So now we look at the next index, and our sum now will become 0 again, right? How many subarray that can make up to the sum of 0? We already had the answer here, which is 1, right? So we increment our count to 1. Right? But then we also need to update this sum because we see it twice, right? The first one is an empty array. Okay, and we keep going to the last one, right? 0, 0 plus 0 is 0. And also, let's say our k is 0. I forgot to mention our k is 0. Right? And yeah, the sum is 0. 0 plus 0 is 0. So how many ways, how many subarray there's to make up the sum of 0? Well, we know we have 2, right? So we need to add 1 to 2. This is 3, right? And this will be our answer. So we can either have negative 1, 1, 0 by itself, or an empty array. Okay, so that is the general algorithm. We just have to keep track of the current sum up to the index as we iterating to the nums array, right? And we can start at 0, right? 1. There's one sub array that can make up the sum of 0, which is the empty array here. Right? We can have our file. We can have our sum, our concurrent sum. But we have to return the cow at the end, right? Okay, so for the I equal 0, I less than nine, I possible, right? We have to keep track about current sum. So sum plus equal number I, right? So if the difference, right? The difference is in our hash map. So sum minus k is in some index. They want to increment our count by the frequency of the sum minus k, right? Otherwise, we will increment the frequency of the sum, right? Of the current sum. So if the sum is in some index, we do some index uh, of sum plus equal 1, right? Else you can do some index sum equal to 1. So that's pretty much it. Uh, Instead of using the brute force approach, we were able to do it in off and hash. The trade-off is off and space because we need the hash map, right? Thank you for watching.